All right, section 5.3, part 2. Got kind of cut off on the end of that last one, but I just wanted to show you at that end there how you type it in the Desmos, and I think I got everything I wanted to say about that said. So picking up here in example 2, and as usual, I have not really mentioned this too much since we got class started, but always consider pausing and trying these on your own before I go through them. It'll serve you better, I think, when you think about it a little first. But at any rate, we're going to look at example 2 here, and the question is it better to invest in an account that pays 5% compounded monthly or an account that pays 5% simple interest? So for this one, they don't really tell us a whole lot of information, but I do know with the compounded monthly, the N will be 12. I also know that R is going to be 0.05 for 5%. And then they tell me monthly, compounding, and simple. So if I just start writing down the formulas here, I'm going to write down the compound formula. I know I'm going to use that at some point. So I'm going to have the F equals the P times the 1 plus R over N to the NT power. And then I'm also going to use simple interest as well, because they tell me that in the second part of the statement there, the second part of the question. So I'm going to have F equals P times parentheses 1 plus RT. So when I look at both of these, I need an N for the compound. I got that. I need an R. Both of them are going to be 5%. So both will be 0.05. But the things that are missing are the T and the P. And with these types of problems, if you're comparing things, you can really see what's happening after 1 year. So you just assume that T will equal 1. That'll be enough time to make the comparison. And you can also assume that the principal, the present value, is just going to be $1. You don't need to have big fancy numbers in there for the amount. You just can start at $1. It makes everything a little easier. So for this one then, for the compound, we'll have 1 times 1 plus 0.05 over 12 raised to the 12 times 1 power. And when you work that out, you get 1.05. And you do have to go out several decimal places with this in order to see it. So, don't get lazy with the decimals. Go out further so that you can really see the difference. And then with simple, we'll have 1, assuming for the present value again, and then plus 0, then times 1 plus 0.05 times 1 for the time. When you work that out, you get just a 1.05. So if you only went out 2 places, you could say, oh, well, they're both the same. But compound interest really does have a slight difference here. And if you start adding zeros to your present value, you would really start seeing more of a gain, because that 116 back there will start playing more of a role. But at any rate, just make sure you go out enough decimal places to see this, and the compound is slightly better. And the more years you go out, the better it is. Okay, so one common way of reporting the interest rate is called the annual percentage yield. Or APY. So you have the APR, which is the annual percentage rate, the stated annual rate, but then you actually have the annual percentage yield. And yield, when you think of yield, don't think of it like when you're driving around and you see the yield sign, you got to pause, make sure nobody's coming or whatever. You want to think about it like crop yield. If you're out farming, you have crops and you're like, how much is my crop yielding this year? I'll produce 17 bushels or whatever. So it's really the actual amount that you're truly realizing from the account, the true yield from the account. And basically it's the interest earned in 1 year on $1 invested. So by comparing APYs, you can easily tell which is the better investment. So for example, you got ATSA has $10,000 to invest and has a choice between two different accounts. One pays 7% compounded monthly. The other pays 7.1% compounded yearly. Which is the better option? And if you didn't know better, you might think, oh, 7.1%, that's a higher percent. That's going to be better, right? Well, this is where the APY can really shine light on the true yield for the year and see if 7.1% yearly is actually better. So let's go ahead and compare this. So let's do the 7% one first. And the APY here, N is going to be 12 for compounded monthly. And we're going to use F equals, we assume $1, so 1 times 1 plus 0.07 for the 7% over 12, because we're compounding monthly, and then raised to the 12th power, 12 times 1 technically, because you always do this just for 1 year. And here you get 1.07229. And if you subtract away the original dollar that's included in this future value, then you see that your APY is equal to 0.07229. So actually a little higher than that stated APR because of the compounding. So now if we take a look at the other 7.1%, the APY here, we're just going to have N equals 1 because it's yearly. So F will equal 1 times 1 plus 0.071 over 1 raised to the first power. If you work that out, you get 1.071. Again, subtract the original dollar that you invested to see the interest, and this is 0.071. So your APY here for this account is just 0.071. So now you can see, using the yield approach, that the 7% monthly is actually better, because compounding 12 times a year gives it a chance to earn a little extra on the interest each month after that first month, and get you ahead of the 7.1 that's only done once per year. So the compounding here, more compounding times are better, even with a slightly lower rate. So 7% monthly is better. More compoundings make up for that slightly lower rate. All right. So that's pretty much everything you're going to be doing in this section. And if you have questions about anything, please ask, and we'll pick up with a more interesting use of the compound interest concept in section 5.4.